In the following lesson, we are going to talk about some important parameters in vaccinology. They are efficacy, effectiveness, and herd immunity. Let's start with vaccine efficacy. Vaccine efficacy is an individual parameter that measures the percentage reduction of a disease in a vaccinated group of people compared to an unvaccinated group. For example, we have two groups of 56 healthy individuals. One is vaccinated and the other is not. We follow up both groups and the number of infections in each group is compared. Then we compare the infected individuals in both groups by calculating the attack rate. The attack rate is the proportion of exposed people that become sick. In the unvaccinated group, 36 out of 56 people become ill, so the attack rate in this group is 64.29%. On the other hand, in the vaccinated group, only 2 out of 56 people got the disease, representing 3.57% of attack rate. Finally, using this data, we can calculate the efficacy, that in this example is 94.44%. However, efficacy and effectiveness are not the same. Effectiveness can be defined as the real-life efficacy and is obtained after the implementation of a vaccine in a given population. The main difference between efficacy and effectiveness is that the latter is obtained in a real-world condition after the vaccine is launched into the market, while efficacy is obtained in a phase 3 clinical trial in an experimental context. Now we are going to understand how an infection is transmitted through the population. When we have an infectious disease in an unprotected population, it can be spread from one person to another without any obstacle. In theory, at the end, all the population could be infected. Now, to understand the dynamics of transmission, we need to first define some basic concepts. The average of new infection that a single individual can generate is known as R0, or basic reproductive number, and this number is directly proportional to the speed of the transmission. Here, we have some examples. When R0 is equal to, we can say that one infected person transmits the disease to 2 other persons. Those 2 persons will now transmit the disease to 2 persons, each generating 4 new cases, and this can go on. Another example, if R0 is equal 5, we can see that each time 5 new persons are infected, and the disease can be spread way more quickly. Another important concept to understand the dynamics of disease transmission is herd immunity. Herd immunity is related to the basic reproductive number, and it is defined as the proportion of persons in a given population that is immune to an infection, serving as barrier for the disease transmission. However, the concept of herd immunity is often confused with herd effect. Herd effect is the reproduction of the infection in an unvaccinated segment of the population, in which a large proportion has been vaccinated. Therefore, herd effect is a form of indirect protection. It is important to mention that we can only have herd effect in diseases that are human-to-human transmitted and do not have a zoonotic or environmental transmission or reservoir. When we have a low vaccination coverage, we cannot stop the transmission chain, so the whole unvaccinated population is now vulnerable. As we can see, the disease can spread through the unvaccinated part of the population, and we don't have herd effect. For example, it is known that infants are the main affected population by Streptococcus pneumoniae, the bacteria that causes pneumococcal disease, making them the main source of its transmission. On the other hand, elderly are also very susceptible to this disease, meaning they are a high-risk population. When infants are infected, they can transmit the disease to the elderly. However, if you vaccinate the infants, they are not susceptible to the infection and therefore cannot infect the elderly, blocking the transmission. In this particular case, vaccinating the infants, we can protect also the elderly by indirect effect. The main concepts of this video are summarized here. For further information, check the additional resources of the module.